All right, so in this section we're going to be looking at, or in this video we're going to be looking at the blue section of your review. And this blue section is all about how to solve these rational equations. And so the process, the thing that I like to do first is after we get everything in factored form, so this is already in factored form, there's nothing I can do to simplify the denominator or the numerators here, is I like to identify what my extraneous solutions could be. Can't remember how to spell extraneous. Oh, E-O-U-S. Okay, the first step I like to do is, and the reason why I like to do that is then if we get an answer, we can always check it and just make sure that it's not going to be our extraneous solutions. And so here we have x plus 4 in our denominator. Remember, we can't have 0 in our denominator, so x can't equal negative 4. All right, so now let's see how we would solve this. So then what we can do is, one of the ways we could solve this is by multiplying everything by your least common multiple, because that'll get rid of all your fractions. And so our least common multiple, our LCM here, would just be x plus 4. So I'm going to multiply both sides by x plus 4. So when we do that, the x plus 4s would cancel out on the one side, and on the left side we would have 1, or we would have 1 equals, and on the right side we would have distribute the 5 through, so we'd have 5x plus 20. So we'd have 1 equals 5x plus 20. So now I'm going to solve this equation. I'd subtract 20 from both sides and get negative 19 equals 5x. And if I divide both sides by 5, we get x equals negative 19 fifths. I check it with my extraneous solution. It's not negative 4. So that would be your answer. X equals negative 19 fifths. All right, let's look at number 2. So again, I'm always going to repeat the same thing if you're watching this video through, because there might be people that are jumping on here just skipping to see this particular question. So if it sounds like I'm repeating myself, that's why. All right, so the first thing I want to do is check to see if I can factor anything out, which I can't factor anything down here. This is already in factored form. So then before I do anything else, I want to identify the extraneous solutions. And the reason why is because then when I get my final answer, I can check it against my extraneous solution and see if it in fact is a solution or not. And so for this one, my only factor in the denominator is x minus 3. So we know that x can't equal a positive 3, because otherwise you'd have 0 in the denominator. All right, so my LCM here would just be x minus 3. So we're going to multiply everything on both sides by x minus 3. By doing that, we get rid of the fraction, which is the whole point. And so now we would have 1 on the left equals, and I'm going to distribute the 6 through to get 6x minus 18. Now I just solve this equation. So I'm going to add 18 to both sides to get 19 equals 6x. Divide by 6, I get 19 sixths. Always check to see if your fractions can reduce. This can't be reduced, so this would be your answer, and we know it's a possible answer because it's not in my list of extraneous solutions. All right, let's look at this one. So this one, we have two factors here, and they're both, nothing can be factored down, so we're going to have two extraneous solutions. We would have x can't equal 3, and x can't equal 0, because if we had 3 or 0 in our denominator, that would result in having a 0 in our denominator. We can't have that. Okay, so we just want to make sure that we do not have this as any of our solutions. All right, so my LCM for this in this problem is going to be x times x minus 3. So we're going to multiply everything times x minus 3. Because what that's going to do is that's going to get rid of the fractions. Okay, we're not multiplying the numerator and denominator, we're multiplying each fraction by the LCM, because that gets rid of the fractions. So now the x minus 3's would cancel out, these two x's would cancel out, leaving me in that first fraction, we would just have 2 times x, or 2x. In the second fraction, I'm going to distribute the 3 that's left over times the x minus 3. So we'd have 3x minus 9. Now I just have to solve this simple equation. So I'm going to subtract 3x from both sides to get negative x equaling negative 9. Well, I can't have that, so we don't want to have a negative here, so we can multiply both sides by a negative or just change it to be positive, but then we have to change that to be positive. Or multiply both sides by a negative. However you want to look at it, we get x equals 9. Again, we check that against our extraneous solutions and it's not one listed, so we know that x equals 9 would be a possible solution. One thing that I haven't mentioned as I've gone through these is you could always check your work by plugging your answer into both equations and make sure that it checks out. So that's one of the beautiful things about algebra is you can always check your answers and make sure you got them correct. All right, now we're getting into a little bit trickier problems. Let's look at number 4. So in number 4, the first step again is to always look to see if you can factor anything further. So x squared minus 9, that's a difference of squares. That factors down to be x plus 3 times x minus 3. All right, before we do anything else, I'd like to identify the extraneous solutions. Because what that's going to do in the end is that's going to help me identify if in fact our solution actually works. And so with this x plus 3, that means that x can't equal negative 3. With x minus 3, that means that x can't equal a positive 3. And the x plus 3, x minus 3, we already have that listed, so we're good. All right, so the next step is to figure out what do we multiply each side by. We're going to multiply by the LCM, the least common multiple. In this case, the least common multiple is x plus 3 times x minus 3. All right, so here's what's going to happen. When we multiply this left side by x plus 3 times x minus 3, we're going to multiply both fractions, both individual fractions by x plus 3 and x minus 3. Oops, I forgot to write this down, but we're going to have this on the right as well. But going back to that left side, both of those fractions get multiplied by x plus 3 and x minus 3. So when we do the first fraction, it gets rid of the x plus 3, but we're left with a 1 times x minus 3. So we'd have x minus 3 for that numerator. Oops, because the denominator is gone. And then we're going to take and multiply that same x plus 3 and x minus 3 times a second fraction. And when we do that, this x minus 3 cancels out that x minus 3 to leave us with the x plus 3 times 1, which would just be x plus 3. And the denominators, remember, are canceled out. They're gone. And so then on the right side, this x plus 3 and x plus 3 cancel out. Those cancel out, leaving us with just 6 on the right. So now let's solve this equation. So x plus x is 2x. Negative 3 plus 3 is 0. So we'd have 2x equals 6. So that means that x equals 3. So that's our answer. But I checked that with my extraneous solutions. That's why we always start with that at the beginning. So that way we can always check our answer against that. And we see that x can't equal negative 3 because it's an extraneous solution. So there's no solutions here. All right, let's look at number 5. So this one, before we start, everything's in factored form, so we don't have to worry about doing that. But again, like we've done on each of the other problems, if you've been watching this video, is we want to find the extraneous solutions before we do anything else, because that'll help us identify at the end whether or not our solution actually works. So my denominators are both x plus 2, so that means for both our denominators you can't have negative 2 as an answer. So let's see so our LCM is x plus 2. So we're going to multiply both sides by x plus 2. So watch what happens with this one. The x plus 2's cancel out here, leaving us with 4 on the left. The x plus 2's cancel out here on the right, leaving us with x squared. Now, if I take the square root of both sides, there's two answers we could get. We could get 2 or negative 2. Anytime you take the square root of both sides, you always end up with two solutions, a positive and a negative. The reason why is because 2 squared will give you 4, and negative 2 squared would also give you 4. But we need to check our answers and make sure that we don't have any extraneous solutions. And what I notice is that negative 2 is an extraneous solution, so that is not part of our answer. So x equals 2 would be your only answer, and that negative 2 would be an extraneous solution. All right, let's look at this doozy of a problem. Number 6. So the first step is we are going to factor anything that we can, and I notice that x squared plus 6x, we can factor an x out, so we'd have x times x plus 6. All right, I always like to identify my extraneous solutions first, because that'll help us see if the answers that we get are actually solutions. And so this x, if I set that equal to 0, that means that x can't equal 0. I already have that represented here, so I don't have to do it again. X plus 6, that's another factor. If I set that equal to 0, I would get negative 6. and then we already have that factor represented, so we don't have to do anything more with that. All right, so the next step is to identify our LCM. Our least common multiple is x times x plus 6. So we're going to multiply everything on both sides by x times x plus 6. Now when we start with this first fraction, so we're going to multiply that times both of those. When we do that to the first fraction, the x's cancel out, leaving me with x plus 6 times x plus 5. And with the second fraction, when we multiply x times x plus 6 times this other fraction, the x plus 6's all cancel out, and there's nothing that I have to do, or nothing I have to multiply x minus 2 by. So we'd have just plus x minus 2. On the right side, whoops, don't need that parentheses. On the right side, this x plus 6 cancels out that x plus 6, leaving us with the x, but I'm going to distribute the x through, so we would have x squared plus x. All right, let's do some simplifying here. So on the left side, I'm going to simplify this piece. That can multiply together. I'm going to FOIL that, so we get x squared plus 11x plus 30. But then we also have to add the x minus 2, and then on the right side we have x squared plus x. So I'm going to simplify some things. I'm going to recognize that I could subtract x squared from both sides. And then on the left side here, we have an 11x plus x, so that would be 12x. And then 30 minus 2 would be 28. So we have 12x plus 28 equals x. Well, one thing I could do is I could subtract 12x from both sides. So then I would have 28 equals negative 11x. And if I divide both sides by negative 11, I get 28. Or negative 28 over 11, or 28 over negative 11, same idea. But that would be your answer, x equals negative 28 elevenths. If I check that against my extraneous solutions, that's not one listed. So x equals negative 28 over 11 would be your final answer. So that is how you do the yellow section, I'm sorry, the blue section of your review.